Video, you're going to learn about mutually exclusive events and non-mutually exclusive events. What's the difference between these two? So when we say mutually exclusive events, these are events that cannot happen at the same time. So take note of this. So here, I'm going to give an example for you to fully understand. From a deck of cards, what is the probability of getting a king or a queen? I know that you're familiar with a deck of cards. There are 52 cards, and there is no such card that is a king at the same time a queen. So it's either a king or a queen. So now, to find the probability of this kind, the mutually exclusive events, we are going to get first the probability of the first event, which is, let's say, probability of getting a king. And now, how many king in a deck of cards? There are 4 kings there. And over 52 because there are 52 cards. So this is sample space, the 52. And then the probability of getting a queen, there are 4 queens also out of 52. Now, to get the probability of getting a king or queen, simply we're just going to combine. Why? Take note of this or. Or means union, and in union we are just combining the outcomes. It means we are just going to add 4 over 52 plus 4 over 52. And this is equal to 8 over 52. Since the denominators are the same here, what you're going to do is just simply copy and add the numerators. Or you can change this to percent. 8 divided by 52 times 100, that is 15.38%. What does it mean? 15.38% probability of getting a king or queen. So now what's the formula for the mutually exclusive events? So we have here probability of event, the first event, so let's have that A. Or means union. Second event, let's have that B. So probability of A union B is equal to the probability of the first event, which is A, plus the probability of the second event, which is B. So this is the formula for mutually exclusive events. Now, for non-mutually exclusive events, these are events that share, take note, share a common elements or outcomes. Share common elements or outcomes. So example again, I'm still gonna use the deck of cards. From a deck of cards, what is the probability of getting a heart or a king? So here, there is a common outcomes here. Now, this is an example because if you're going to, if you're familiar with the cards, we know that we can have a king at the same time a heart, right? Okay, so they are, or there is a common outcomes here. You can get a heart at the same time a king. So now, how we're going to get for or calculate for the probability? So the probability of getting a heart or king is equal to, first you need to get the probability of getting a heart. So how many hearts all in a deck of 52 cards? From ace to king, there are 13 hearts, or there are 13 cards that has that heart symbol or we have spade, flower, heart, and diamond. So 13 out of 52. Now, we have the probability of getting a king, and there are 4 kings only, so 4 over 52. Now, but here, there is one card that is a king, at the same time a heart. So what are we going to do with that? Is we need to subtract that. So here, we are going to add this first. This is 13 over 52 plus 4 over 52 minus that one card that is a king, at the same time a heart. So now, they have the same denominator. So what we're going to do is just copy that and perform the numerator. So 13 plus 4, that is 17, minus 1, that is 16. So 16 over 52, or again, you can change this to percent. 16 divided by 52 times 100, and that is equal to 30.77%. So the probability of getting a heart or king is 30.77%. So the formula here for this non-mutually exclusive events, so we have P, A, or probability of A union B is equal to, this is A is the first event and B is the second event. Union because it's OR, okay? So the probability of the first event, or A, plus the probability of B, minus this 1 over 52 here, that is the intersection. That is the probability of A and, or intersection B. What does it mean? The probability of getting a card that is a heart and at the same time a king. So intersection. Okay. So now I'm going to show to you using Venn diagram. So for mutually exclusive events, this is the Venn diagram looks like. Okay, so they are separated. For non-mutually exclusive events, we have here the A and the B, and this is now the intersection. Okay, this one here. This is probability of A intersection B. That's all for this video, and thank you for watching. Please share my videos.